Alrighty, hello again. Today what we're going to do is we're going to talk about how to solve systems by substitution part 2. Right? So last time we did some systems by substitution where they were both like y equals and you just set the two pieces equal to each other and then everything's all fine. On these ones they do get a little bit trickier, but we're going to talk them through, right? So this is what's going to happen when one equation is in slope-intercept form and one equation is in standard form, right? So just jump right in and take a look at our steps, right? So to solve a substitution where, again, one is in one form and one is in the other, we need to start by substituting the slope-intercept equation into the standard form equation. Right? And if you don't quite remember what those are, right, hopefully you remember slope-intercept, right? Slope-intercept is y equals mx plus b. Standard form is the one that we don't use quite as often, right? But standard form is ax plus by equals c, right? So you're going to have one that looks sort of like the one on the left, one that looks sort of like the one on the right, and what we're going to do is we're going to kind of smush the mx plus b stuff into the other equation. After that, we'll be able to do our normal steps, right? Solve for the variable, substitute that answer back in one of our original equations, and figure out what the second one is after that, right? So let's just jump right in. This is one where I think that reading the steps is kind of confusing, but when we see it, it might be a little bit easier. So already, right, we've got one equation that kind of, like this top one looks sort of like y equals mx plus b, right? It's, not entirely the same, right? Because the x and y are kind of swapped, but that's okay. This other one does look like ax plus by equals c, right? So basically what we're looking for is one equation to have the variable all by itself with an equal sign, and then the other equation has got all of its variables on the same side with no variables on the other side, right? That's kind of what we're looking at. So what we're going to do here, right, and last time we talked about like, oh, well, y is equal to this and y equals this, so they equal each other, right? It's going to be a little similar to that, right? If I know that x is equal to 2y minus 4, right? What I know is that the other equation has an x. It's 3x minus 5y equals negative 11. So what we're going to really be doing, right, and excuse me, this is going to look a little bit messy for a second, but I'm going to erase it before we go into the problem, is that we're going to take all this stuff, right, 2y minus 4, and since that's equal to x, we're going to literally just smush it right in for that x, right? So again, that might seem a little bit weird, right? Let me kind of write out what it's going to look like, and it hopefully will make a little bit more sense. It's not going to look pretty, I promise you that. So what we're going to do is we're going to take this second equation, and again, what we're doing is we're plugging in that blue part, 2y minus 4, for that x. So it's going to be 3 times whatever x was, 2y minus 4, minus 5y equals negative 11. All right, so again, all I've done so far is I just replaced the x with what it's equal to, which is that 2y minus 4. Right? So if that's a little bit hazy, right, this is one of the barriers of doing this by video, right? Rewind a little bit, kind of listen through the explanation one more time, and if it still doesn't make sense, just bear with me. I think it might click as we kind of go through them, and if it still doesn't, follow along as best you can and ask me about it when I see you in person, okay? So I've substituted in 2y minus 4 for that x. What I need to do now, right, is that I just have this equation. I can just solve this out, right? So I'm going to go ahead and distribute that 3 to everything in those parentheses. That's going to be 6y minus 12, and then everything else still along with it. All right? And then, again, now we're just, oops, I probably could have drawn this a little bit earlier. That's all right. We're just kind of simplifying this, right? I've got these two like terms over here. I've got 6y minus 5y's. So if I had 6 and I took away 5, I'm left with 1y. Still with that minus 12, and it still equals negative 11. After that, all I gotta do is add 12 to both sides to move that on over. Get that away from the y's. 1y which we can also just call y, is equal to 1. Cool. All right, so we've got the first part of our answer. Y is equal to 1. Right? And again, just like we saw before, the only real different thing that we're doing here is just that first step where we had to, plug in that blue piece wherever x was, right? After that, it was just solving an equation, right? It's not a very pretty equation, but that's okay. Sorry to keep sliding all around. So the next part of what we need to do is we still need to figure out what the other variable is, right? So I know that y is equal to 1. I got to figure out what x is. And again, there's going to be usually an easier equation of the two to plug it back into, right? In this case, it looks like it's that top one there, right? I don't have to worry about moving too much stuff around. The x is already going to be equal to whatever's on the other side. So I'm going to have that x is equal to 2 times that y we just found minus 4. Right. When I go ahead and simplify that, 2 times 1 is 2. And then 2 minus 4 is negative 2. All right. Draw a little box around it, and there we go. That's it. All right. So again, only real big difference there is that first step. Right. After that, it's the same old thing that we were just doing on the last lesson. Right. Now, that's not to say that that first step isn't tricky, right? It is a little weird to wrap your mind around at first, but if you get it, right, then everything else is pretty much the same, right? Let's try another one out. So this one, we've got 3x minus y equals negative 2, and y is equal to 2x plus 12, right? So again, what I want to kind of do is remember which one has the variable by itself already, right? So we know that y is equal to all of this stuff over here, 2x plus 12. In the other equation, I have that y, right? So again, what I'm going to do is I'm going to be taking 2x plus 12, that whole big piece, and smushing it into that other equation for y, right? That's what we want to be doing here, right? So in order to write that out, and I'm going to be taking that equation we're smushing it into and just rewriting it. So you got 3x minus, and then everything that the y was, 2x plus 12. Right, and you'll notice that I'm still putting parentheses around it, right? It's not a bad idea, especially on this one when we've got that negative floating around, right? That is going to make a difference on how we're going to handle this after we've plugged this in, right? If the color coding helps, that's what we plugged in for y, right? It's because y is equal to that, we can just slide it right in place of it. So from here, right, again, I'm going to kind of get my divider line because we're going to be solving this out to figure out what x is. And the reason that I, again, wanted to put it in parentheses is because that negative sign is affecting everything on the inside of here, right? So I just drew some distribution arrows from a subtraction sign, which might seem a little bit weird, right? Don't forget, there is a little invisible 1 hanging out there. So it's like we're going to be distributing negative 1 to each one of those things. So we're going to get 3x, negative 1 times 2x is minus 2x. Negative 1 times positive 12 is minus 12. All right, so as we can see, that negative sign did play a different part, right? It not only turned the 2x negative, it also turned the 12 negative, right? So that is an important little, nitpicky bit that we got to be careful of. All right, next step, I've got these two like terms that I can smush together, right? If I had 3x and then I am subtracting 2x's, I'm left with just a single x. Everything else hasn't changed yet until this step where we move that 12 to the other side. Right? So when we move that 12 to the other side, negative 2 plus 12 is 10. All right, there we go. So x is equal to 10. Right? So again, just that first step is the nasty piece, right? Everything else is stuff we've done before. After that, I'm going to plug that back into one of my original equations. And again, feel free to choose whichever one you want. I find that the y equals 1, the one where the variable's by itself, is easier to plug it into. But, do your own thing. I'm going to plug it into that second one. We've got y equals 2 times that x, which we now know is 10, plus 12. Okay. After that, we've got y equals 2 times 10 is 20. And then 20 plus 12 is 32. All right, and there we go. Right. So this is actually a good example of why we, you might be thinking to yourself like, well, why wouldn't I just plug these both into Desmos and figure out where they intersect, right? So sometimes, it's good to be able to do this algebraically, right? Because sometimes it's actually faster than like getting out of a computer and going to the website and plugging it in and, oh, I typed it in wrong and oh no, and we don't want to do this by hand necessarily on a graph because 10, 32, right? That's where our answer would be. Not many graphs that I'm making myself are going to go up to 32 on the y-axis, right? I'm not really going to be going that far up, right? So this is where, doing them algebraically can be helpful, right? Right. Ooh. Let's try one out with fractions. Yikes, right? But it's going to be okay. So just like before, right? The only thing that's going to be different about the fractions is how we're solving it, right? Our first step is going to stay the same, just like it was with the last lesson. I know that x is equal to 2/3 times y, right? In the other problem, or on the other equation rather, we have an x. So I'm going to be smushing all this 2/3 y in for that x. All right, when I do that, it's going to look something like this. We're going to have 4y minus 2 times all that nastiness, 2/3 y. And it's going to equal 2. So unfortunately for us, right, there's not really a nice clean way to clean up the fraction right off the bat, right? We could go through it, but it's a little complicated sometimes, right? It might not always work out for us. So what we're going to do here is we're just going to multiply 2 times 2/3, right? We're going to take care of that. So, again, don't write this out where I'm going to write it because I have the ability to easily erase. If you want to put it off to the side somewhere, that's fine. But when I'm doing, this multiplication here, right? Negative 2 times 2/3 y, it's going to look something like this. So negative 2 times 2/3. Well, negative 2 is the same thing as negative 2 over 1, right? So, just like the other times that we've handled fractions, we're going to start off with that. When I multiply, the top multiplies the top. So negative 2 times 2 is negative 4. The bottom multiplies the bottom. 1 times 3 is 3. And then when we get to negative 4/3, right, there's not really a nice, easy way to simplify that, right? We could put it as negative 1.333333333 repeating. But sometimes it's easier, trust me on this, it's easier to leave it as a fraction, right? So what we're going to have is that's going to come out as negative 4/3. Okay. So my first step is just to do that. So this is 4y minus 4/3 y equals 2. All right. So this is where we're going to be, simplifying this as best we can. So now that there's no parentheses kind of screwing everything up, what we can do from here is now we can get rid of those fractions. Right? And again, remember from the last lesson, fractions are just division. The opposite of dividing is multiplying, so that's what we're going to do. And all we need to do is multiply by this denominator. Right? If we multiply everything by 3, it's going to get rid of the fraction. Right? So 3 times 4 is 12y. When we multiply by that fraction, if you want to do the multiplication off to the side to double check, that's fine. But it's just going to come out as negative 4y. And then don't forget to bring that all the way to the other side to get that 6. All right. After that, 12y minus 4y, right? These are like terms that we can smush together on that side. So 12 minus 4 is 8y. Right? And then after that, we got to get rid of the 8. Divide both sides by 8. Right? You might be noticing something. We kind of have an issue. 6 divided by 8 doesn't come out too cleanly. Right? It comes out to 0.75 if you plug it in a calculator. But again, it's going to be easier for us if we leave this as a fraction. One step that I want us to try and get a little better at, if you're not feeling too confident with it so far, is to reduce your fractions. If I have 6 over 8, I can cut both of those numbers in half evenly. So 6 over 8 is the same exact thing as 3 over 4. All right, so when I get y equals 3/4, that's what I kind of want to move forward with. Right? It'll still work out if you plug it in as 6/8. Your numbers will just be larger, and sometimes that's a little bit more difficult, right? But it's not the end of the world. But if you are able to kind of get a little better at reducing fractions, right, go for it. All right, after that, still got to figure out what it's going to equal on the other piece. What I'm going to do is I'm going to plug it into that second equation, right? And you might think I'm crazy, like, Mr. Pog, why would you plug it into the one that has the fraction? That sounds awful, right? But if I just multiply the fractions, that's all I need to do, right? With the other one, I'd have to plug it in and multiply and then solve some stuff out and move stuff around, right? So instead, I'm just going to get it over with, right? So I have x equals 2/3 times that y that we just found out was 3/4, right? And now that we've done a couple problems with fractions, hopefully this doesn't actually seem so bad when you think about it, right? We're just multiplying these two fractions together. So x is going to stay the same. When I'm multiplying fractions, the top multiplies the top. So 2 times 3 is 6. The bottom multiplies the bottom. 3 times 4 is 12. And 6 divided by 12 is the exact same thing as 1/2. Boom, we're done. Right? That's all we need to get through on that one. Right? So, again, fractions are not particularly super duper fun or anything, right? But after we kind of get those under control, it's just the same old thing, right? Solve some stuff out, plug a number in, figure out the other number, and then that's it. All right. We're going to take a look at 2 more today. Or by today, I mean for this lesson. I don't know when you're watching this. You might have watched 4 other ones today, right? And this one, again, looks a little gross, but it's going to be all right. All right, so we're going to start off the same way. We're just going to evaluate what we've got for equations here. We've got that y is equal to 0.4x minus 2.4. Right? On the other one, we have 4y minus 10x equals negative 18. So you can see that I was highlighting as I went, right? We're going to take all that blue stuff and smush it in for the yellow stuff in that second equation, right? Because y is equal to all that, so we can replace y with all that stuff. And when we do that, it's going to look something like this. It's going to be 4 times y, which is 0.4x minus 2.4. And then everything else is the same. Minus 10x equals negative 18. Right? And again, this is not one where it's like, oh yeah, that looks great. Man, I can't wait to do this, right? But, we can work with decimals, right? They're not the absolute worst. Sometimes they're easier than fractions. Sometimes not, but sometimes they are. All right, first thing I'm going to do is I'm going to take care of this distribution, right? I'm going to multiply that 4 into those parentheses. So 4 times 0.4 is going to be 1.6 with an x. 4 times negative 2.4 is going to give me negative 9.6. And then everything else hasn't changed yet. All right, if you wanted to use a calculator, and actually this goes for every time, right? As always, you can always use a calculator if you want to. So I know that sometimes multiplying with fractions seems a little funky. So after that, I've got some like terms on that left side. I've got 1.6x minus 10x. All right, so if I have 1.6 minus 10, I'm going to end up at negative 8.4 x's. All right. And again, everything else kind of just comes down as it is. After that, I still need to get those x's by themselves. So I need to move that 9.6 to the other side. All right, after we do that, right, we're going to get negative 8.4x is equal to whatever negative 18 plus 9.6 is, which is negative 8.4. And boy howdy, it looks like we're going to be okay if I divide both sides by negative 8.4. Lucky for us. It's all going to come out nicely. X is equal to 1. Phew, really dodged that one. Whew, that could have been so bad. Can you imagine having to plug in like x is equal to 6.24? That would not be too fun, right? After that, if x is equal to 1, I again got to plug that back into one of those original equations there, which is why I zoomed back out. Give ourselves a little arrow there. I'm actually going to plug it into the first one there, because even though it's got decimals, it looks like the y is all by itself and might be a little bit easier to just move stuff around for. So y is equal to 0.4 times that x, which is just 1, minus 2.4. Okay, when we do that, 0.4 times 1 is just 0.4. And then when we do that subtraction, 0.4 minus 2.4, right? It gets rid of the 0.4, oops. And all you're left with is negative 2. Well, bam, there we go, right? See if we can fix that shaded in box real quick. But other than that, that's all we really need to do here, right? So again, decimals, not always better than fractions, right? They're just like cumbersome for your eyes to look at, right? It's like, oy, 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 right? But at the end of the day, it's all the same. Okay. You might have looked ahead a little bit and been like, word problems, gross, right? For number 5, what I'm going to do is I'm going to do this one out on here. I'm going to upload it as part of the PDF notes that I do later on. What we're going to do is we're going to do 6 together, right? But for 5, I'm just going to kind of skip over it for here. If you do want to go back and take a look at it, I will upload it as part of these notes when I put them in our class notes folder and all that stuff. So be sure to check there if you want to. I can also talk you through it in person, but in the interest of time, let's take a look at number 6. So an algebra textbook from 1881 has this problem. It says a farmer purchased 100 acres of land for $2,450. They paid $20 per acre for part of the purchase and $30 per acre for the rest. We want to figure out how many acres they bought at each price. All right, so decent chunk of stuff going on in here, right? 100 acres total, $2,450, $20 per acre for some of it, and $30 per acre for the rest. So what we're going to do is we need to set ourselves up with 2 variables to start us off with, right? So what I'm going to do is I'm just going to use X and Y. And what we're setting those up as is the 2 different groups of acres, right? So the 2 different groups here is that, for some of them, we only paid $20 an acre. And for some of them, we paid $30 an acre. So I'm going to say that X is equal to the number of acres at $20. I'm going to say that Y is the number of acres at $30. All right. So what we can do now is we can take our information from the word problem, and since we have some variables, we can actually work something out. So what I'm going to do is I'm just going to, set myself up a little brace over there so I can write in my system. Right? We know that we purchased 100 acres of land for $2,450. Right? We paid $20 for part of it, $30 for the rest. So if I take 20, right, and I multiply it by X, that's going to give me the cost of all of those acres in that first group, right? It's $20 for each of those X acres, so 20 times X. If I then add on 30 times Y, that entire other group, that should capture all of the purchasing that I did, right? Which means that total is $2,450. Right? So again, this is the one that's talking about money, which is why I did, all right, 20 times however many acres cost $20, 30 times however many acres cost $30. Add them together and that's your total, right? The other piece is a little bit trickier to, it's not trickier to write, but it's trickier to figure out from the problem. If we purchased 100 acres total, right? Well, I have these 2 groups, right? I know that X is however many I bought at $20 and Y is however many I bought at $30. So if I have X plus Y, right? The first group plus the second group, that should equal out to be 100 acres, right? So this is the system that we can now work with. But you might notice a bit of a problem, right? They both have all of the variables on the same side. Oh no. So what we can do here, right? And this is something that, you can do on other types of problems, right? Which is why I wanted to show it, is that you can actually just take this equation and change it up a little bit, right? So what we're going to do is we're going to solve for Y, right? In order to get that Y by itself there, I don't really need to do too much, right? I just need to subtract that X to be on the other side. So when I do that, I can say that this is the same thing as Y equals 100 minus X, right? So I haven't changed the equation too much, right? Like I haven't changed any of the numbers or what it equals out to be or anything like that. All I did was I just moved that x to the other side so that we had the y by itself, right? What that's allowing me to do now is that I know that y is equal to 100 minus x, right? And I can plug that y into that first equation there, right? So then it does become like one of the problems you were doing earlier. All right, so I'm going to zoom back out a little bit. Hopefully not too much, right? And I'm just going to go ahead and plug all that into that first equation. It was 20x plus 30 times that y that we just kind of worked out, 100 minus x, equals 2450. Right? And again, this is not a problem where it looks all nice and pretty, right? But it is one that we can solve out. Right, so I'm just going to kind of focus on this. When I do this, I need to go ahead and distribute that 30 on into there. All right, so we're going to get that 20x plus 30 times 100 is going to give me 3,000. And 30 times negative x is negative 30x. All right. Same as some of the other ones we've run into. We have some like terms to combine. All right, so if I had 20x's and I take away 30x's, I'm down to negative 10x plus 3,000 equals 2450. What I need to do from here is I need to get all those x's by themselves, so that 3,000 has got to go over to the other side. All right, and then we'll get negative 10x equals 2450 minus 3,000 is going to give us negative 550. Divide both sides by negative 10 to get rid of that from the x's. And we're going to get 55. All right, so what does that 55 mean? Right, that's the big question, right? It's because this is a word problem, we do have to worry about what that is. So if we go back to what x was, right? X was the number of acres that we bought at $20 a piece. So that means that we bought 55 acres at $20 a piece. Right? So what this is going to allow us to do, right, is that we now know that x is equal to 55, right? Way down there in that tiny little blue box. Right? What we need to do is we need to plug that back in to figure out what y is. So I'm going to go back to my original equations, right? We had x plus y equals 100. I'm going to plug it in there. Excuse me. Been recording too much today. So if we have x plus y equals 100, right? We know that the x is 55 plus y equals 100. What I needed to do is I need to move that 55 away from the y's. We're going to get that y is equal to 45. And that's it, right? That's the other half of our answer. Right? Honestly, you probably could have figured it out without having to work it out mathematically, right? If I had 100 acres, the other piece is 45 of them. So we had 45 acres at $30 a piece. Right? And that's where we want to get to with stuff like this, right? We now have these two quantities. We know what they equal, right? Because the x was the $20 a piece, the y was the $30 a piece. And that's what we're at, right? So again, we're not going to worry too much about word problems. What I would say is if you kind of really get these ones down, right? Stuff like 1 and 2, then that's pretty okay, right? If you still have questions, be sure to ask about them next time you see us, because that's what we're here for, is to help you out with math, right? And as for now, I guess that's it. I'll see you next time.